So in today's video, we'll be looking at trigonometric ratios. More specifically, we'll be looking at sine, cos, and tan. The most important thing about figuring out which ratio to use, whether we use sine, cos, or tan, is actually in making sure you've labeled your right-angled triangle correctly. So let's say this is the unknown angle theta. From there, we can go, okay, well, the hypotenuse is always going to be opposite the right angle. The opposite is the side opposite the unknown angle, and the last side is the adjacent. So same thing here, we've got our unknown angle. The hypotenuse is the side opposite the right angle. This side here is the opposite because it's opposite the unknown angle, and the last side is the adjacent. One last example. This one is the hypotenuse. That's the opposite, and this is the adjacent. So this is a handy little trick that you can use to find which trigonometric ratio to use. So if you look at this SO, CA, TOA, it's actually an abbreviation, and it will tell you which trigonometric ratio and which sides. So SO is for sine, which is opposite over the hypotenuse, which we can see here. If we have this unknown angle here, the hypotenuse is this one, which will make 5, and the opposite is the side opposite the angle, 4. So we can therefore say that sine theta is 4 over 5, because it's the opposite over the hypotenuse. CA stands for cos, which is adjacent over the hypotenuse. So if we have this angle theta, the hypotenuse is opposite the right angle, and the adjacent is this side here because it's the side not opposite the unknown angle. And TOA stands for tan, which is the opposite over the adjacent. So taking this angle here, we know that the opposite is going to be this one because it's opposite the unknown angle, and the adjacent is that side. So let's look at this example. We're going to be finding the unknown angle in these two triangles. So I'm going to make this our unknown angle here, and we're going to say this is 5 and this is 4. So let's label our triangle. I'll just change the color. So the side opposite the right angle is the hypotenuse. The side opposite the unknown angle is the opposite, and the last side is the adjacent. So we have the value for the hypotenuse and for the adjacent. So out of SO, CA, and TOA, we can see we have the adjacent and the hypotenuse. So we will be using CA, which is cos. So cos of the angle theta equals 4, the adjacent, over 5, which is the hypotenuse. Then we rearrange for theta, which equals cos inverse 4 over 5. And we can put that into our calculator, and we will find that theta equals 36.9 degrees, which is to 1 decimal place. So let's have a look at triangle 2. If we take this as our unknown angle theta, and I say, okay, well, this is going to be 5 and this is 12. First thing we want to do once again is label our triangle. So this is the hypotenuse, this is the opposite, and this is the adjacent. So taking SO, CA, and TOA, we can see we have the opposite and the adjacent. So we will be using tan theta equals 12, which is the opposite, over 5, the adjacent. Rearranging, theta equals tan inverse 12 over 5, and theta equals, once again, pop it into your calculator, we get 67.4 4 degrees, which is to 1 decimal place. Now let's use these trig ratios to find an unknown side. So, taking this first triangle here, first thing I'm going to do is label it. So, this is our hypotenuse, this is our opposite, and this is the adjacent. So instead of going sine theta, we can actually see that we're given the value of theta. Theta equals 30. So having a look at so, ka, and toa, we can see we have the opposite and the hypotenuse, so we'll be using sine. Now, we're told that 30 is our theta. So instead of going sine theta, we're going sine 30, which equals then the opposite, which is x, and the hypotenuse is 15. Now, we want to rearrange to get x by itself. So what we do is we multiply both sides by 15. Then this divided by 15 and the times by 15 cancels out. And we end up with 15 times sine 30 equals x. And then x equals, pop that in your calculator, and we get x equals 7.5. Now let's have a look at triangle 2. So once again, first thing, label the triangle. This is the hypotenuse, this is the opposite, and that's the adjacent. So looking at so, ka, and toa, we can see we have the adjacent and the hypotenuse, meaning we will be using cos. Now once again, theta is our given value of 43, so cos 43 equals the adjacent 5 over the hypotenuse x. Now, we want to get x by itself, so the easiest way to do that is actually multiply both sides by x, which means this divided by x and the times by x cancel out, and we have x cos 43 equals 5. Now, to get x by itself, if we divide both sides by cos 43, we can do that. So, divide by cos 43, and then these will cancel out, and we're left with x equals 5 over cos 43. Now, if we put that into our calculator, we get x equals 6.8, which is to 1 decimal place. Now, here are some extra practice questions. Once again, please pause the video and give these a go by yourself. Come back if you need any help, if you get stuck, or if you just want the solutions. I'll be popping the working out down below. These are the last two practice questions. Once again, please pause the video and then come back whenever you're ready.